Hello and welcome to another video done by the Cal. So in this video, we'll be going over a problem that we made ourselves for the April Fool's contest. And that was a 4-question contest that we made on April Fools. And this problem, I actually wrote it. So let's get to the problem. Prove that 2n minus 1 factorial is equivalent to n mod n squared if n is prime. So the first thing that we notice is if we take 2n minus 1 factorial, it has one factor of n. So the reason is, in this factorization somewhere, we get 1 times 2 times 3 times all the way till times n. So we do have a factor of n here. But since n is prime, we don't get the second factor. So this is not equal to 0. And now we just need to show it's equal to n. Now, I'll just write out the rest of the factors, n plus 1, all the way till 2n minus 1. So, the first thing that we can do is divide out this n. Now we have all these other factors, and what we can do is we'll take it mod n, so we've taken a mod n, and since it's 0, we've divided by n. And now let's take it mod n again. So essentially we're trying to take a mod n squared, so we can take a mod n twice. Now we need to take this, and I'll write this in a more concise form. Let me just erase that. Oh, sorry. For some reason it's not working, so I'll just write it again. 2n minus 1 factorial over n. And we need to try to find that mod n. So these first n minus 1 factors, so n minus 1 factorial, by Wilson's theorem, we know this is equivalent to negative 1 mod n. Now the rest of the factors, we have n plus 1 all the way till 2n minus 1. If we take each of these factors mod n, we get 1 times 2 times 3 all the way till n minus 1, which is the exact same thing that we had in the first n minus 1 factors. So this is also equivalent to n minus 1 factorial. So this whole expression, in other words, 2n minus 1 factorial over n is equal to, right on the top, n minus 1 factorial squared. And since we know by Wilson's theorem, n minus 1 factorial is equivalent to negative 1 mod n, we know that n minus 1 factorial squared is 1 mod n. So essentially, the remainder when you divide it by n squared will be n multiplied by m times n plus 1 for some value of n. And the reason is, the first time it was divisible by n perfectly, so that's the factor of n. And the second time we had n again, except we're adding 1 because we 2n minus 1 factorial divided by n mod n is equal to 1. So that's why we have to add this extra 1. And that means the remainder is in the form mn plus 1, where m is any integer. So it could be like negative 7, 50, it doesn't really matter. And now that we have this, we can just expand this, so we get m n squared plus n. And we're trying to find this mod n squared. And we know that mn squared is already divisible by n squared, so we only have an n remaining. And that's essentially what we wanted. We wanted to prove that this is equivalent to n mod n squared. And we were done with that, because mn squared is divisible by 2n squared, n squared. So we don't even have to worry about that. And we are done with the problem. It was just simply crossing out the first factor of n, then using Wilson's theorem on the rest of the factors, and then finding it mod n squared, which is what we wanted at the end of the problem. Thank you for watching the video. If you have any questions, leave it in the comments or in our Discord server. which I've added to the description below. And if you were wondering what the April Fool's contest was, I've also attached a link to the PDF of all the problems. So if you wanted to check out the rest of the problems, you can look at them. And we might post solutions to the rest of the problems soon. Thank you for watching.